Angielski język. My name is Slavco Velickov.
Good morning, ladies and gentlemen.
Bentley Systems. It's a pleasure being here. We started, I remember, with Tomasz and Professor Paweł Lichner 7 years ago or 8 years ago. That was first time in Warsaw. About 40 people, enthusiasts, starting this Stormwater Poland conference. And now it's great to see that there are more than 500, I think, registered participants at the conference. So it's attracting a lot of attention. And obviously the topic is very important for the future as well. So I would like to present a little bit what we are doing in Bentley in terms of the new vision and the new developments for modeling software solutions for the stormwater networks, but also we're moving towards what we call digital twins. Because traditionally we have been working with CAD drawings, still we are doing that. Then we move towards 3D and BIM, building information model, which is very important. As built infrastructure, we would like to do it in 3D, but more and more we see that the industry is moving towards digital twins. It's basically digital representation of the networks, whether it's a stormwater network, whether it's a wastewater network or a potable water network, and also the business processes around that can serve throughout the complete life cycle of the infrastructure. Bentley Systems, we are present here in the conference, is basically a NASDAQ-listed company, international company. We have offices in Warsaw and Krakow, and also provide software solutions and trainings in Polish language and also technical support as well. We are covering the complete infrastructure, including water, wastewater, and stormwater infrastructure. Now, about 5,000 colleagues work at Bentley Systems. They are mostly engineers. So engineers from civil engineering, structural engineering, geotechnical engineering, etc. And as I mentioned, we have a lot of clients as well in Poland, primarily the water companies, then of course the municipalities, but also the engineering companies which are working and benefiting from these solutions. This is just a summary I would like to present. We attended recently, of course, the Singapore Water Event 2 weeks ago. That was the also in Copenhagen. IWA water event. Some of the key trends which are important there and which is very important for this conference as well. You can see the number one was climate change and adaptation of the more extreme weather events. Professor Lichner also talked about the importance of having this accurate estimations of the probable, for example, rainfall events and the probable floods that will come there. Because sometimes we see in the statistics that things are changing. And of course, with the statistics, we have a good basis, but sometimes all of these rainfall events are outside of the statistics as well. We never seen that before. So adapting our infrastructure in a responsible way to cope with the climate change is very important. Number two, digitalization came up. Of course, I mean, one of the things that happened in COVID is we worked all from home for almost 2 years, I would say. And what we learned from that is that digitalization is very important, because what I noticed in the Netherlands, for example, even Netherlands is quite developed country in terms of digitalization. Many of the water companies didn't have access to their network. They don't have access to their data, to their drawings, etc. So digitalization was speed up, I think, in the last 2 years, and it's great to see that it's taking place also in Poland. But that's not only software solutions, it's about the people and it's about the business process. So it's a complete transformation of the organizations which are driving digitalization. Also, what we have seen in the last couple of years is that many departments are working in silos. So, for example, the engineering department is designing the stormwater network, but then when it comes to a building and operation and asset management, there is no connectivity. That's why this digital twin, sort of overarching digital model, which is combining existing data, it's very important that we bring all of the data available together in order to benefit. So our vision and what we are working in Bentley is really providing this digital line of sight, as we call it. As I mentioned, digital twin is it's a little bit of buzzword nowadays. Everybody is using it. But what does it mean, digital twin? So digital twin is a digital model, a representation of the infrastructure. If we are designing, for example, a retention pond, like we saw many of the manufacturing suppliers are here, we would like to have a digital model of that, understand the performance in a real time, and also, for example, serve that for the operation and maintenance across the complete life cycle. So the same digital model can be used for planning, if you like to do, planning of a low impact development in terms of mitigating risk of flooding, for example, then design various scenarios and options in the analysis. Then the same digital twin is used for construction as built. So we have a digital model, how it's constructed, and the same digital model is used then for operation and maintenance in 50 to 100 years to come. So that's the role of the digital twin, basically supporting all of the functions in the organization. It's not just a fancy, visualization or presentation of the model. Now, what is the key differences between traditional, conventional way of doing things and with a digital twin? So I will not read. You can see that one of the advantages is turning the static data into more real time. So then instead of, looking at spreadsheets, etc., more advanced data analytics. So we are talking a lot about here hydraulic modeling, understanding the behavior of the system. And that model should be constantly updated, even automatically. And of course, instead of looking at our maps and drawings and profiling, so maybe the digital twin has some intelligence inside which can tell us where are the bottlenecks automatically, where are the alarm and alerts which might happen, what should be the inspection time, for example, of a certain chamber or a certain manhole, etc., and to facilitate better and faster decisions. So moving forward, I would like to show you, for example, a couple of things of the digital twin. First is capturing the reality. If you're doing blue field or a green field projects, for example, we want to do a low impact development in a certain area, put a retention tanks or ponds, you need to capture the reality very carefully. So elevations are very important, contextual, trees, etc., auxiliary infrastructure. So Bentley has technology that can use satellite images, drones, geodetic measurements, just put them together. They crunch the numbers and they present your base digital model for design, basically. So that's the first step. Second is managing information in a sort of connected data environment where there are drawings, there are models, of course. There's some GIS data, there might be rainfall information, etc. So all of this can be modeled in the same environment and with the same contractors, because if it is, for example, city of Katowice that is driving this project, and many companies are working in the project, so this connected data environment starts building the digital twin. So you're building it as we go. Design drawings, etc., which can be later utilized to manage that digital twin. Of course, modeling is very important. We hear today a couple of presentations about modeling, and yesterday as well. So this is just an example of sewer jams 2D, 2 dimensions. So the wastewater network and the storm drainage network, whether they are separated or combined, you can run that analysis, if the else analysis, do, for example, different components which are important, like from the suppliers and manufacturers. We have retention pond, green roof, ponds, etc. So do this analysis and see what is the optimal analysis in order to implement that still in a 2D environment. Then I'm moving a little bit towards a 3D environment, and sometimes we call that BIM, Building Information Model. So it came out from the building industry indeed, but it's very applicable for the infrastructure industry as well. So in this example, it's the same model, the same sewer network or a storm drainage network, but in a city context. So you see in the background there is a reality mesh, which is showing the city, for example, of Katowice or Gdańsk, etc. Then you have the 3D design, and automatically you can compute immediately with a hydraulic model what is happening if I move this manhole, what is the profile, what is the storage area, what is the peak flow, etc., and whether this design is good to be constructed later on. So this is more and more, we see that engineering companies are using this heavily. And because of the capabilities like clash detection, very important. If you are designing something new, and there is, of course, underground infrastructure which is there, so you need to know the corridors, the excavation corridors, the volume of the earth which is there. So clash detection is becoming also very important, because underground is also very busy. We are also moving in our discussions with the colleagues that came also to the stand, we are moving towards real-time operation. So once we construct this intelligent storm drainage systems, a sustainable urban drainage system, or low impact development, as we call them as well, which is low impacting the people, but also the environment, we see a trend that many of these intelligent retention systems are equipped with sensors. They are monitoring flows, they are monitoring water levels, they are monitoring the pumps, for example, which are pumping, etc. How to bring this data together and how to bring the model that we already created in our design phase to become more operational. For that, we developed a sewer site in the last 3 years. We developed, and this is an online platform which basically supports storms and sewer networks operation and real-time visibility. The building blocks are very simple. First of all, GIS data. So we have the GIS data. Everybody has some sort of GIS. Second building block is a hydraulic model, preferably, because we cannot measure everything. The model will tell us what are the bottlenecks. And finally, the telemetry, SCADA. So rain gauges, many municipalities in Poland now are investing in rain gauges. But how to use this data? Once we have the rain gauges, we would like to feed this data into the platform. Then, of course, monitoring pumping stations, monitoring water levels, monitoring flows, blockages potentially into the system. So these three components are really a must-have to create such an intelligent or an online platform. And more we see, for example, like integrating work orders management system. If the company needs to, the city of Katowice needs to maintain, inspect certain manholes and certain pipes, that can be also plugged into the platform and can show in a real time where the people are, basically. So once we have this connected data, it's not replacing anything. It's basically connecting the existing data into this multi-dimensional digital twin. Of course, you can do fantastic things later on. So first of all, network monitoring. Second of all, what is capacity in terms of retention? What is the current alerts? Are there any events happening currently? If a storm event is coming, predicting the volume, the peak volume, and even anticipating pumping in advance, etc., etc. So this becomes really a platform for a real-time simulation and monitoring. Just to give you an idea how it looks like, so this we implemented this in Porto, we implemented this in Rotterdam, for example, we implemented this in DC, Washington, and now we are talking with Warsaw Water. We would like to start a small pilot, both on the sewer network and the water network as well. And this is really a real-time web enablement emergency platform, basically. So if you would like to simulate some if-then-else scenario, if I need to switch off this pump because we need to maintain them, or there is a planned scheduled downtime, etc. So which manholes will be surcharged? If you want to monitor, for example, the rain gauges and compare them with previous events, we can see based on anticipated weather forecast and the rain gauges, what they're telling us. With the simulation model, you can compare dry weather, so business as usual, like today, and a wet weather, which is coming. So what is the anticipated level, how much flow it comes, and again, 7 days ahead. And this is very good, of course, for managing the retention systems, but also for managing the wastewater treatment plant, because the wastewater treatment plant in a combined sewer system doesn't like peaks. It likes a steady flow, which can be treated primary, secondary, tertiary, and then released into the environment. So alerts and events. The software uses machine learning techniques because we have a lot of data now coming in from sensors, from the models, and the software can recognize automatically, some events and say, okay, this is mostly runoff volume and infiltration potentially, etc. And that event can be generated automatically and sent to the operational team, which are monitoring the SCADA system and the network itself. So I will not go into details. This is just to show you where we are working. One of the things, like in Stockholm, for example, this is city of Stockholm, there are a lot of political parties, green parties, NGOs, etc., which want to know what the city is doing. And this is publishing that data. So if there is a big project, a pipeline which needs to be constructed, or a tunnel, sewer tunnel, which needs to be constructed for retention, for example, like the sewer tunnel in London, like the sewer tunnel, for example, in Stockholm. So these are big pipes which needs to be constructed. These are affecting people. obviously. It's affecting for 2-3 years construction. You can publish this information even on internet or on the website of the municipality, of the water company, and ask for feedback. Okay, what is your feedback regarding the project? More communication towards the citizens, which is very important to get the buy-in for this type of projects as well. Finally, visualization is always good in order to show to the decision makers what we mean by, a climate impact, heavy rainfall events. This is city of Lisbon, by the way. This is, you probably have been there. This is the city centrum, is the basically municipal building. Like in Katowice, we have the municipal building, and mostly what happened is basically the municipal building was flooded during rainfall events. And while visualizing things to the politicians, to the decision makers, they immediately understand what is the project about and what impact we will make. So communication and visualization is very important. As I mentioned, I will not go too much in details, just to share two international examples with you. This is city of Porto, for example, where we implemented this water site and sewer site, so both for the water network and the storm drainage network as well. So they have some low impact development, green infrastructure, including the beaches. So the water is collected, of course, from the storm, but it comes to the beaches. It's a very touristic area, and sometimes if you have discharges which are environmentally, unfriendly with the dirty water, etc. So the beaches are closed, and you have to put, red flags on the beaches, etc., etc. So this is a complete system, which is an integrated water cycle management. Today we're talking only about stormwater, but it's not isolated from the drinking water, from the sewer system, from any other, from irrigation, etc. So holistic approach sometimes is also necessary in this type of projects. This is some of the reportings. I will not read. So reduce customer complaints, first of all. So anticipate better information. Then reduced sewer collapses, like in Schleswig region. A lot of ground movements, like in the Netherlands, for example, as well, because of the mining, but also because of the soft soils. You have a lot of collapses of sewers and the storm drainage network. So predicting those in advance is also good. As well. This is a Northumbrian water in the UK, so predicting storm and sewer overflows. You probably read, so for example, Thames Water was discharging illegally in their combined sewer systems to the Thames Water, and they were fined about £70 million just recently. So big penalties are imposed on companies if they, discharge into the environment. So getting such a platform that combines all of the information is beneficial for predicting these sewer overflows and pollution events. In a summary, if you'd like to discuss, of course, many of these solutions, there are many solutions and technology on the market, but for a specific project, it's very important to understand, first of all, the use cases. What is most important? Is it more retention of the water? Is it more longer term, for example, sustainability of the complete system? Is it more, for example, the flood risk management, which is there? So understanding the use cases is very important, and based on that use cases, choose the right technology and the right approach. So I want to thank you. I want to thank the organizers and everybody for inviting us as well to participate in this event. If you would like to discuss a little bit more in details, we are there at the booth, so during the coffee break, and get in touch with us. So thank you very much. Dziękuję.